Well, good evening. I am going to try to explain mole conversions for you here in the next 10 to 11 minutes. And mole conversions means you are going from mass to moles, or from particles to moles, or moles to particles, or moles to mass. In mass, typically we're going to be talking about grams. For particles, we usually talk about atoms or molecules. And so in the big scheme here, this is what it looks like. I can go from particles to moles, moles to mass, mass to moles, moles to particles. And things that you need to remember here is that 1 mole is equal to 6.02 times 10 to the 23rd of whatever it is that you're talking about. If it's atoms or students or whatever, and 1 mole is equal to what we call the molar mass. So let's talk about this. This diagram, you've been looking at a sheet of diagrams about mole conversions, and I guess now that you've figured out what my favorite one is, moles is the heart of chemistry. Sorry. Anyways, if I'm going to go from moles to items, we use 6.02 times 10 to the 23rd, and depending on what direction you're going, either you're going to end up by multiplying or you're going to end up dividing by that number. And I've given you conversion factors here and here. So if I'm going from moles, let me do this, moles to items, I'm going to be using this conversion factor right up here. This conversion factor right here. And if I'm going from items, which would be either atoms or molecules, to moles, you end up dividing by 6.02 times 10 to the 23rd of whatever those items are. Okay? On the other half of the diagram over here, if I'm going from moles to mass or mass to moles, I'm going to use the molar mass. And so again, if I'm going in this direction here, I'm going to multiply by the molar mass. If I'm in moles trying to get to grams, we multiply by the molar mass over 1 mole. If I'm in grams trying to get to moles, I'm going to divide by the molar mass. Easy, huh? Well, let's talk about something that's pretty cool. If I have 1 atom of carbon, if you look on the periodic table, its atomic mass is 12. And if it's 1 atom of carbon, it's 12 atomic mass units. Okay? Now, if I have a mole of carbon atoms, that's 6.02 times 10 to the 23rd. They have a mass of 12 grams. I mean, do you see the connection here? 1 atom, 12 atomic mass units, but 1 mole of carbon atoms, 12 grams. No, wait, that's just so cool. I'm going to have to look at that for a second. There, I'm done. Now, if I want to calculate the molar mass, I've been using that term. What you need is a formula of what it is that you're talking about here. And in this case, I've got, what's the name of this? You're right, it's potassium chlorate. Now, you're going to use the periodic table, and when I do that, I'm going to look up all of the atomic masses of the different elements in that formula. I'm going to look up potassium, and if you look that up, it's 39.1 grams. And that brings me to something. You want to round all of your atomic masses to the nearest tenth. That's going to be our general rule. So 39.1 grams. Chlorine is 35.5 grams, and oxygen is 16.0 grams. Make sure you have a periodic table out and looking so you see this. Now, from the formula, I can tell I have one atom of potassium, I have one atom of chlorine, and this 3 here tells me I have 3 atoms of oxygen. So I multiply by the number of atoms. That's going to give me 39.1, 35.5, and 16 times 3 is 48.0. Add those together, this is the molar mass. In other terms, if I had one particle of KClO3, it would have a mass of 122.6 atomic mass units. But if I have a mole of KClO3, that has a mass of 122.6 grams. Okay, so let's do 2 conversions, and then I'm going to let you go on your own. Here's the problem. If you have 4.50 grams of KClO3, potassium chlorate, how many moles of KClO3 do you have? So I am going from grams to moles. Look at your mole conversion diagram. What does it say you have to use? If I'm going from grams to moles, does it say you have to use molar mass? Right, the molar mass. Good for you. Now, does it say that you have to divide or multiply? Divide. Great. Okay, so you got to divide. So you need to set up the problem like this. And I call this cross that I have right here a grid. So you need to set your grid up. This is what you're given. This is a conversion. This is what you are asked to give. Now, if I do that, I write in 4.50 grams of KClO3, and I know 1 mole of KClO3 is 122.6 grams. We calculated that on the back screen. Grams of KClO3 divide out, and so I have 4.50 divided by 122.6. That's going to give me an answer of 0.0367 moles of KClO3. And notice I was using 3 sig figs in my answer or in my problem, so I am going to have 3 sig figs in my final answer. That wasn't too bad, was it? Let's try one more. Alright, so here we have how many molecules of KClO3 would that be? We just finished calculating how many moles of KClO3, so that's what we are in right now, moles of KClO3. And now I have to use 6.02 times 10 to the 23rd. Now, do I multiply or do I divide? And if you're going from moles to molecules, this is what your conversion needs to look like. Again, moles of ClO3 needs to divide out. So, put your values in your problem. 0.0367 moles of KClO3, draw your grid, and 6.02 times 10 to the 23rd molecules KClO3 divided by 1 mole of KClO3. Moles of KClO3 divide out, and so 0.0367 times 6.02 times 10 to the 23rd. If you do this on your calculator, this is what you get here. You get 2.21 times 10 to the 22nd molecules of KClO3. That's pretty cool. So, you have a bunch of problems. I would love for you to get together in some support groups here and work these problems. Make sure in your notebook you're showing me the grid. Show me how you set up your conversions, put your given numbers in, and then solve the problem. So, here's your Japanese for the night. Gambatte kudasai. Minasan wa gambatte kudasai. Do your best. Thank you.